So good afternoon everyone and welcome to this lecture. In today's lecture we are going to start with a brand new topic, and that is thermodynamics. And thermodynamics as always starts with thermometry. Now what do you mean by thermometry? Thermo means temperature. Do you know this? Thermo means temperature and metry means measurement. So thermometry basically stands for the measurement of temperature, and this is how thermodynamics starts. Now, to start thermodynamics, the name of the chapter is also heat. First of all, we have to understand the term heat.
Yes,
Heat.
sir.
What do you mean by heat? What do you mean by heat? Heat is a form of energy. So remember, I call heat is energy in transit, and this is how we
Transfer
define
from one
heat.
point.
Heat is energy in transit.
Yes, sir.
Heat is only defined when it is in transit. Now, what do I mean by the term transit? When I use the term transit, I means it is getting transferred. It is getting transferred from one point to another,
Point.
and why is it getting transferred from one point of another, point to other? Is because of difference in temperature. So heat is energy in transit, which gets transferred from one body to the other
Point to
body
other point.
because of difference in temperature.
Temperature. Yes.
What type of quantity is heat? It is a scalar quantity. Energy is always scalar. The SI unit of heat is same as joule. The CGS unit is also known as calorie, and 1 calorie is equal to 4.18 or 4.2 joules. These are the things that you must remember about heat. Yes or no? We know this.
Yes, sir.
And quickly go through this. Now, we are going to see a lot of terms in this chapter. One of the terms that we are going to get a lot of times in this chapter is internal energy. Now, this internal energy of a body or any gas is because of the random motion of its molecules. We will understand this motion of molecules in the chapter known as kinetic theory of gases. But because of this random motion of these molecules, every body has something known as the internal energy of the body. Now, when it is inside the body, the energy is known as internal energy. But when it is getting transferred from one body to other body, a part of this internal energy which is transferred from one body to the other body because of temperature difference, that is
And
known
heat.
as heat.
Yes, sir.
So heat is a form of energy. It is only defined when it is getting transferred from one body to the other body, and that too only because of difference in
Change in temperature.
temperature. We have seen how much is 1 calorie. 1 calorie is 4.2 joules. But there is also one more definition of calorie in terms of heat transfer. And you must remember this definition. It is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius, and that change in temperature should be from 14.5 to 15.5 degrees Celsius. So that is what you must remember about heat. We will get to know more about heat in the coming days, but right now we are going to concentrate on the term temperature. Have you noted this down? I'll give you 2 minutes.
Mm.
Note it down. Let me know once you are done. Then let's move to the concept of temperature. What is temperature? What is temperature? Anyone can define what is temperature? Yes.
Degree of hotness or coldness, sir.
Temperature, as very rightly said, you must have heard this definition of temperature in your lower standards as well. And this definition is still valid, that temperature is the degree of hotness or coldness of a body, and heat will always flow from a body of higher temperature to a body of lower temperature. Yes or no? Do we understand this?
Yes, sir.
Then there is a term that will come just now after we are seeing the term of temperature, thermal equilibrium. Have you heard this term thermal equilibrium before? Have you heard this term thermal equilibrium before?
Yes,
Thermal
sir.
equilibrium. What do you mean by thermal equilibrium? When someone says two bodies are in thermal equilibrium, they basically means that they are at the same temperature. So thermal equilibrium means the bodies are at the same
Same
temperature.
temperature. Yes, sir.
We understand this?
Yes, sir.
Okay. Then temperature is one of the 7 fundamental quantities. Dimension is T or theta. We understand this?
Yes, sir.
The SI unit is Kelvin. We know this. Yes or no?
Yes, sir.
When a body loses heat, its temperature falls, and when a body gains heat, its temperature rises. There is one more thing that can happen is the change of state. We will also see that. But normally, if a heat is given to a body, the temperature of the body may rise and temperature of the body may fall. Yes or no?
Yes, sir.
Okay. Now, there is one more place where you give heat to a body, but the temperature does not change. That is because the state of the body is changing. We will see that thing too. Maybe in today we will start with that topic as well. Anyways, so far so good.
Yes, sir.
Have you noted this down?
1 minute, sir.
Okay. Let me know once you are done.
Sure, sir.
Well, we have understood the concept of temperature.
Yes,
Now,
sir.
to measure the temperature, we need a temperature scale. Now, temperature is measured by a thermometer. Every thermometer has markings on it, degree Celsius, Kelvin, or whatever. Those markings are basically known as scales. So the next heading is scales of temperature.
Scales of temperature.
To measure temperature, we need a scale. Now, every scale of temperature that we normally use it has two fixed points. Every scales that we construct
Two fixed
has
points.
two fixed points. And what are those two fixed points?
Low freezing point and upper freezing point.
Huh? Lower freezing point and upper freezing point. Both are freezing points.
Upper melting point, lower freezing point.
The first fixed point is the freezing point of water. It is called as the lower fixed point. The second point is the boiling point of water. It is called as the upper fixed point. For any scale, two fixed points are there: freezing point of water and boiling point of water. And for any scale, for any scale, the reading on that scale, if the reading on that scale is x minus freezing point divided by boiling point minus freezing point is a constant. For any scale that you can make your own scale to measure a temperature, but you have to take two fixed points for that scale. One should be the freezing point of water, one should be the boiling point of water, and this ratio should be same. Now there are three or four different scales of water. Not every scale is used, but I'll give you a table where you will get to know about all these scales, their lower fixed points, their upper fixed points, their number of divisions. So you will have to note them down. Most of them you would be knowing, but still, this is a table where we have all those scales. The Celsius scale, the most widely used scale, degree Celsius, lower fixed point is called 0 degree, upper is called 100. The number of divisions are 100. For Fahrenheit, used in US, degree Fahrenheit 32 degree F, 212 degree F, the number of divisions are 180. Do we understand this? Yes or no?
Yes, sir.
So you can just write them down. I'll give you 2 minutes to write it down. Everyone understands this? Yes or no?
Yes, sir.
2 minutes. Then let's move ahead. I have already told you that the reading on any scale minus the upper fixed point divided by minus lower fixed point divided by upper fixed point minus lower fixed point, which is the boiling point minus the freezing point, is constant. Yes or no? Now, based on this, if you use for all these scales, you will get a relation between all these scales. And this is the relation. First, listen to me and then write. C minus 0 divided by 100 will be equal to C minus F minus 32 divided by um, 212 minus 32 and so on. Kelvin minus 273.15. If you make your own scale, if I make my scholastic scale, so the reading on Astic scale minus the freezing point on my scale divided by boiling point minus freezing point on my scale would be a constant. Do we understand this? So we can have this shortcut relation between these quantities. Remember this because there could be a question where you might be asked to find out the relation between these temperature scales. So for that, it is important, and I'll give you time to note it down. I'll give you 1 minute to note down all these relations. Let me know once you are done. You have noted this down. Then comes a couple of questions, simple question based on those concepts. And this is the first one that we are going to do. The graph AB is shown in the figure is a plot of temperature in degree Celsius and degree Fahrenheit. What is the slope of the line? Remember, centigrade or Celsius are the same. Here it is written centigrade. So it is not centigrade. You can just make it to Celsius. This is Celsius. Celsius and Fahrenheit graph is drawn, and you have to find out the slope of the line. What is the slope of the line? Yes, my dear friends. Anyone? No one knows it? You just noted it. What is the point of noting if you can't solve a question based on that?
Pi by 9, sir.
5 by 9. It should not have taken so much of time. C by 5 is F minus 32 by 9. You can write it like this. So you can write C as 5F by 9 minus 5 into 32 by 9. So the slope of this line is basically 5 by 9. It's a very simple question. Yes or no?
Yes.
Everyone understands this? Can I give you one more question? Okay. This is the next one. And it comes on your screen now. The temperature of an iron piece, change from 30 degrees Celsius to 90 degrees Celsius. What is the change in temperature on the Fahrenheit scale and change in temperature on the Kelvin scale? I'll give you 2 minutes to give me the answer. What you have to remember in this question is, you know the formula of conversion of Celsius into Fahrenheit. You don't have to convert 30 degrees Celsius into Fahrenheit and 90 degrees Celsius into Fahrenheit. Have you done that? Don't have to do that. Remember, JEE is a test of your speed. Change in temperature. Change in temperature, if I say change in temperature of Celsius by 5 will be equal to change in temperature of Fahrenheit by 9 straight away. Because that term, which is a constant term, it will get cancelled both sides when you find out the change in temperature. And that is what you have to remember. Do you understand what I'm saying?
Yes, sir.
So change in Fahrenheit will be 9 by 5 into 60. As simple as that. Now, the second thing that you must remember, that the Kelvin scale and the Celsius scale are same in terms of the divisions. So change in temperature on the Celsius scale and change in temperature on the Fahrenheit scale, on the Kelvin scale will always be same. Do we understand this?
Yes, sir.
Okay. This is the next question in this category. The freezing point on a thermometer is marked at 20 degrees Celsius and boiling point is marked as 150 degree. This question could be put in this way, that I have made a new scale. In the new scale, the freezing point is 20 degree Aztec 20 degree A and boiling point is 150 degree A. How much will a temperature of 60 degrees Celsius be on my scale? So I ask the question in this way, I ask the question another way. The question remains the same. I hope you understand the question. Yes or no? You will get 2 minutes to solve this one.
That formula, sir.
We have the formula X minus freezing point is 20
Yes, sir.
divided by boiling point is 150 minus 20, that must be equal to the temperature on the Celsius scale is 60 minus 0 divided by 100 minus 0. From here you can find out the value of X. Once you have the value of X, you have your answer. Yes or no? No, yes.
Yes, sir.
Okay. So this question could be asked in different ways. I hope you have understood. Whether it is asked in any way, the question remains same. Okay. Now these are questions on the temperature scale. Now let us move on to what measures these temperatures and how do we measure these temperatures? We measure it by a device known as
Thermometer.
thermometer. Now, what is a thermometer? Everyone knows it. It's a device that can measure the temperature.
Temperature.
Now, the problem is, how does a thermometer know what is the temperature? How does a thermometer know what's the temperature? Remember, whenever we are using different scales, freezing point of water is not 0 degrees Celsius. We have just assumed that whatever it is 0 degrees Celsius, so that we have a reference to make our scales. We know how to make our scales, but how do we make a thermometer? Now, thermometer must be based on some concept. What we have seen in day-to-day life, that with temperature, some physical properties of a body change. Can you give some examples? When temperature changes, some physical property changes. Can you give some examples of that? Anyone knows any physical property of any body or any substance that changes because of change in temperature?
Yes, sir.
Example?
Mercury.
Mercury? What mercury? Mercury is a physical body or what?
Water, sir.
What water, sir? I'm talking about a physical property. What physical property of any body? Any body, water or mercury or human beings or iron or whatever. These are physical bodies. They have physical properties. I'm talking about which physical property changes. If you can find out certain physical properties that change, and that too if they change linearly means on a straight line, it becomes easy and convenient for us to make a thermometer. So we must be able to find out some thermometric property, we call it. We must be able to find out some thermometric property of a body that changes when the temperature of the body changes. Now we come back to the same question. Can we think of any thermometric property of any body that may change when the temperature changes? And we see it every day in the morning when your mom or you make tea. the volume of a liquid changes. If you heat up the liquid, the volume of the liquid changes. Volume of any body changes. Even if it is a solid body, its volume also changes. We don't just see the change because it is too less. Volume of liquid and gas changes drastically, and therefore that is one thermodynamic property, thermometric property, that changes when the
Sir,
temperature
got it.
changes. Pressure of the gas changes when the temperature changes. Volume of the gas changes when the pressure changes. Resistance of a wire changes when the temperature changes. Yes or no?
Yes, sir.
So you can use these 4 thermometric properties basically to create a thermometer. You can put a liquid in a small capillary tube. When the temperature changes, actually the volume of liquid changes, but you can see that change in volume by the change in the length in the mercury in the capillary tube. Yes or no?
Sir.
That is one property. The change in the volume of a liquid, whether it is mercury or water, the volume of water does not change so much for small changes in temperature, and that is why we use mercury. We can use that thermometric property. We can use that thermometric property to create a scale. So all the scales that you see are based on all these thermometric properties. It could be number 1, the volume of liquid. It could be number 2, pressure of gas. Number 3, volume of the gas. Number 4, the resistance of a wire. We use a platinum wire because its resistance is almost changing linearly, and it changes even for small changes in temperature. Do we understand this?
Yes, sir.
So based on this, you can have different types of thermometer. Based on the first concept, we have the liquid thermometer. Do we understand the meaning of liquid thermometer? Liquid thermometers are based on what? The property of change in the volume of the liquid.
Okay.
Liquid thermometers. Liquid thermometers. Now, liquid thermometers, they are based on the property of volume of liquid changing. Yes or no?
Yes, sir.
Again, these liquid thermometers have 2 fixed points. One is
Uh, freezing point.
the freezing
Boiling.
point, another is the boiling point.
Yes, sir.
So how are these liquid thermometers made? You put a liquid in a capillary tube and you dip it in water. When the water is melting, water is freezing into ice, and you mark that length. Then you take this thermometer and put it in boiling water. The temperature will rise. You mark the
Right.
length,
Yes,
and
sir.
then you divide it into 100 parts to have the Celsius scale. So the temperature on the Celsius scale is put like this. Do we understand what I am saying?
Yes, sir.
So any temperature on the Celsius scale can be written like this. The length of the liquid column at that stage minus length at 0 degrees Celsius divided by length at 100 degrees Celsius minus length at 0 degrees Celsius multiplied by 100 degrees Celsius. Do we understand how I've written this formula? Do we understand how I've written this formula?
Yes, sir.
I've assumed that the change in length will be linear, and that is how I've written this formula. We understand this?
Yes,
If I
sir.
had to draw a graph, if I had to draw a graph between the temperature in degrees Celsius and length, the graph I assume will be like this. The graph would be going in a straight line like this. Do we understand this?
Yes, sir.
This is your 0 degrees Celsius, and probably this is your 100 degrees Celsius. Do we understand what I am drawing here?
Hmm.
This length will be length at 0 degrees Celsius. This would be the length at,
100 degrees Celsius.
and at any point between 0 and 100, if the temperature is T degrees Celsius, I can find out its length, and that length minus L naught is a straight line. L minus L naught divided by L 100 minus L naught into 100 degrees Celsius should give me the temperature on the Celsius scale. Yes or no?
Yes, sir.
If I had to write the temperature on the Fahrenheit scale, how will I write it?
Hmm.
Length at Fahrenheit,
L
whatever temperature,
minus
minus length at
length at 32 by
length at 212.
L212 minus L32. Yes, sir.
No, sir. Multiplied by 180 degree Fahrenheit, because there are 180 divisions between them. Do we understand this? Or it has gone above our head saying bye bye? Yes or no?
Yes.
Yes or no? You understand this?
Yes, sir.
I'll give you 1 minute to note this down. Everyone has understood this?
Yes, sir.
Note it down. Then let's move ahead, sir, from liquid thermometers. Let me now move on to solid thermometers. I mean, when I say solid thermometer, I mean resistance thermometers. Now, resistance of a wire, platinum wire to be very precise, is almost linear, and hence we can make a resistance thermometer based on it. Remember, resistance of a wire, or should I say resistivity of a wire, is directly proportional to the temperature T. Let me not write T as small t, as capital T. And we can make a thermometer based on this. The actual formula for this is resistance of at temperature T is R naught into 1 plus alpha into T in degrees Celsius, where alpha is a constant which is known as the temperature coefficient of resistance. Have you heard about this? Have you heard about this? Might not have heard about this, but this is a constant. From here, I can write the formula for resistance for temperature at for temperature in degrees Celsius. I can write, I will find out the resistance, subtract the resistance at 0, resistance at 100 minus resistance at 0, and multiply it by 100. Do we understand this?
Yes, sir.
To find the temperature in degree F, R minus
Minus
R32
divided
divided
by
by
R212
R212
minus
minus R32
R032 into
multiplied
180.
by 180, and I will get the answer in degree F. Here I will get the answer in degree Celsius. We understand this?
Yes, sir.
I'll give you 2 minutes to note it down. Now coming to these thermometers based on gases. Now, this thermometer based on gases were actually made for the Kelvin scale. Now, for the Kelvin scale, you don't have two fixed points. These two fixed points have a problem because freezing point and boiling point of water is not constant everywhere. It actually depends on the pressure, atmospheric pressure. The atmosphere, if the pressure is very less, the boiling point and freezing point also changes. So these thermometers are not good, they are not universal. A thermometer made in India can only be used for thermometer made in India. In fact, a thermometer made in India in Chennai cannot be used to find out the temperature in Himachal Pradesh because there is the difference of altitude. So all these thermometers are basically useless. So to have a universal thermometer, we come to gaseous thermometers, and in gaseous thermometer, there is only one fixed point because
Okay.
these gases, this thermometer based on pressure of gases or volume of gases, one temperature is always 0 Kelvin, and 0 Kelvin is the temperature where we don't know what happens because we have not yet attained that temperature. But one temperature is 0 Kelvin. The other temperature, the other temperature for this gaseous thermometer is taken as the triple point of water. So when we come into thermometer based on gases, gas thermometers, these gas thermometers are basically made on Kelvin scale. They are made on the SI unit Kelvin scale. And they have only one fixed point. The other point is always 0 Kelvin. And that one fixed point is the triple point of water. Have you heard about this triple point of water?
Yes, sir.
What is this triple point of water? It is the temperature, pressure, where water can
Water,
exist in all the three
all
forms.
are in equilibrium.
It can exist as water, it can exist as vapor, it can exist as
This
ice.
has ice.
And
Yes,
this
sir.
triple point of water, we have found out that this triple point of water had a temperature 0.1 degrees Celsius. 0.1 or 0.01? I think it is 0.01. Written 0.1. 0.0 0.01 degrees Celsius, and that 0.01 degrees Celsius was written as 273.16 Kelvin. Do we understand?
Yes, sir.
273.16 Kelvin. So for all these gaseous thermometer based on gases, the fixed point is the triple point of water, and that is given the value 273.16 Kelvin. Do we understand this?
Yes, sir.
Here also we have two types of thermometers. We have the first type, which is known as constant pressure gas thermometer. Here the pressure of the gas is taken as constant.
Constant.
So pressure is taken as constant. So when you understand that the pressure is constant, the volume will be directly proportional to the Kelvin temperature.
Temperature.
Yes or no?
Yes, sir.
So the formula for this becomes any temperature on the Kelvin scale will be volume of the gas divided by volume on the triple point multiplied by 273.16. Do we understand this?
Yes, sir.
So that is how you can find the temperature on the Kelvin scale from this thermometer. Sometimes you might get a question where instead of Kelvin scale, they would be using that 0 degree and that 100 degree wala scale. In that case, you can use that formula V minus V0 divided by
V0
V100 minus
minus P0
V0 multiplied by
multiplied by 100.
100. If you want to find the temperature on the Fahrenheit scale, you can use the formula V minus V at
V32 by V12
V212
minus
minus
V32
V32.
into 180.
but it is more likely used for Kelvin scale.
Kelvin.
I'll give you 2 minutes to note it down. One type of thermometer is known as constant pressure. So the next thermometer will be known as
Pressure. Volume. Volume thermometer. Constant volume. అప్పుడు ఏమైతుంది?
constant
Directly
volume gas
proportional
thermometer. And if the volume of the gas is constant, you can understand that pressure will be directly proportional to the
to
temperature on the
temperature.
Kelvin scale. So you can have this formula for this. Temperature on the Kelvin scale will be pressure, observed pressure of the gas divided by pressure of the gas at triple point multiplied by 273.16 Kelvin. If you want to use this formula for Celsius scale, P minus P naught upon P 100 minus P naught multiplied by 100, the answer would be in degrees Celsius. If you want it in the Fahrenheit scale, P minus P32 divided by P212 minus P32 multiplied by 180.
180 Fahrenheit.
Everyone understands this? Yes or
Yes,
no? No,
sir.
yes. Then you can solve this question based on this. I'll give you 2 minutes to solve this question. A thermometer is graduated in millimeters. It registers -3 millimeter. Now you can call it pressure, you can call it length, whatever. It registers -3 millimeter in pure melting ice and 22 millimeters when it is in steam at a pressure of 1 atmosphere. What is the temperature in degrees Celsius when the thermometer registers 13 mm? I'll give you 2 minutes to give me the answer. So we have an answer here. Which one?
B, sir.
B, sir, is correct. 16 by 25 into 100. You can straight away write temperature on the Celsius scale is, if you write in terms of length, L minus L naught divided by L 100 minus L naught multiplied by 100. Yes or no?
Yes, sir.
Everything is given to you. You can just put the values, get the answer, and stay happy. Yes or no?
Yes, sir.
Then you can solve this question as well based on the same concept. I'll give you 2 minutes. It's a question on resistance, but we have already seen the formula, so I'll give you 2 minutes to solve this. The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 300 Kelvin, its resistance is 1 ohm. What is the resistance? The resistance will be 2 ohm at what temperature? So much of time to solve this. Why it was so difficult? Tell me that first. Why you have taken so much of time? Remember, JEE is a test of your speed rather than test of your understanding. Why so much of time? You already know the formula. I given you the formula of resistance. Resistance at temperature T is R
It are
naught
not
into 1 plus
1 plus
alpha T,
alpha
where
T.
R naught is the resistance at temperature 0 degrees Celsius. Yes or no?
Oh, yes, sir.
That is the answer. You can see resistance at temperature. Remember, it has to be in degrees Celsius. 300 Kelvin is how much in degrees Celsius? 27
20.
divided by resistance at temperature T. I don't know what that temperature is. I have to find out that temperature. That will be equal to R naught will get cancelled. 1 plus alpha is 0.00125
125.
multiplied by 27 divided by 1 plus 0.00125 into T. And this RT is given as 2. Yes or no?
At least 2.
And this is given as 1. 1 by 2, you should get the answer. It might require some calculation because this is a very small quantity, but that was all that you had to do. Do we understand this? Yes or no?
Yes, sir.
That's it. That was the topic on thermometry. Have we understood this? Yes or no?
We understood, sir.
Now we move on to the next thing, and that is known as thermal expansion. Just now we have seen what we have seen. What we have seen that when the temperature of a body changes, if everything is okay, if it's not changing its state, the temperature of the body changes, the body expands. Yes or no?
Yes, sir.
That is known as thermal
Thermal expansion.
expansion. So whenever a body is heated, whenever a body is heated, it expands normally. This phenomena is known as
Thermal expansion.
thermal expansion. Now, why this thermal expansion happens? See, in this body, we have a large number of atoms and molecules which are in constant motion. Yes or no?
Yes, sir.
Now, when the temperature of the body rises, their amplitude of vibration also rises. Yes or no?
Yes, sir.
And all of these bodies, they want to stay in a state of maximum stability. And the state of maximum stability is when the potential energy is minimum. Do we remember this work, power, and energy?
Potential energy, sir.
Do we
Yes,
remember
sir.
that? Now, that is the reason for thermal expansion. When the
When
temperature increases, the amplitude of vibration increases, and this potential energy curve is not symmetric. Now, because it is not symmetric, when their amplitudes of vibration increase, what happens is their potential energy is minimum when the distance between them increases. And that is why whenever you heat a body, because of the asymmetry, because of asymmetry, because of asymmetry, remember asymmetry, it is not symmetric. Because of asymmetry, because of the curve being not symmetrical, because of increase in vibrations, the average distance between them increases, because when the distance increases, then only they can have minimum potential energy. Do we understand this?
yes, sir.
And that is why what? When any body is heated, it will expand in volume. We understand this. We just have to remember this curve, that this curve is not symmetrical. And because of increase in vibration, the average potential, the average distance increases, because only because of increase in that average distance, the potential energy is minimum. Do we understand this?
So, yes, sir.
Please note it down. Let me know once you are done. Now, let us move ahead and let us do 2 or 3 very simple things. I've seen them come in exams, so should not miss it. Suppose you have a body like this. A square plate or a rectangular plate like this, and then you heat up this rectangular plate, which dimension of the body increase? A is the length of this body, B is the breadth of the body. There is a hole in this body. C is the diameter of the whole of the body, and D is the distance between that hole and the upper edge or the lower edge. Which dimension of the body increase, or which decreases, which increases, which will remain same? Do we understand the question?
Yes, sir.
So I'll put the question also if you want to see the question. Which dimension of the body change, which increases, which decreases? Yes, what do you think? A rectangular plate has a circular cavity as shown in the figure. If we increase the temperature, then which dimension will increase? Yes. What is your answer?
ABD increases, sir.
All of them increase, nothing decreases. Do we understand this?
Yes.
Remember, it's a question that has come in.
Sir,
Yes.
will C not decrease, sir?
The body does not expand in the hole. Imagine there is no hole and there is full metal, it will expand, no? So hole or no hole doesn't matter.
Okay.
Do we understand this? Body expands completely. This one then. This is a disc with a hole. Which things increase, which thing decrease? R1, R2, R2 minus R1. Yes. What is the answer for this one? Which one will increase, which one will decrease, or which one will remain same? Huh? No answer? I'll give you 2 minutes. R1 increases. Everyone understand this. R2 increases. Everyone understand this. What about R2 minus R1? It also increases because the increase in the radius R2 is not same as increase in the radius R1. It is more than that. And therefore what?
Everything
All of
increases.
them increase because this expansion is proportional to the area also, and we will see that. See, if this is a rod and this is another rod of the same material, but one rod is shorter and the other rod is longer, and I heat it to the same temperature, will they expand similarly or will they expand differently? Will the change in length be same or different?
I will.
It will be different, no? Yes or no?
Yes, sir.
Who will expand more? Who will expand less? That is the next topic. Who will expand more? Who will expand less?
The one which is
The one which is
full length, more length.
the one which is longer will expand more.
Ante.
The one
Yes.
which has more area will expand more.
Expand more.
That's it. So everything increases. Do we understand this? Now we are going to deal the first thing, and that is expansion of solids. We are moving at a good pace. Well done. Are we able to understand or everything going above our heads?
I understand.
Huh?
We understand. Sir. R2 minus R1.
Or
R1
everything going bye bye? We are just there. Okay. Now remember,
ఏం చెప్పింది సార్ ఇందాక?
whenever we increase the temperature of any body, whether it is solid, liquid or gas, all bodies always expand in volume. Always, all bodies always expand or contract in volume. All the things that we see are three-dimensional. Everything has a volume. But you have seen in the chapter on gravitation and before also, there are some bodies, say for example, a very thin wire. The length of the wire is very large, but the width and the thickness of the wire is very small. Now, when you heat this wire, it will expand in volume, but the expansion in breadth and thickness would be very minimal. You will not be able to make out how much it has expanded in breadth and thickness. But the expansion in length, because length is very large, you will see the expansion in length. Yes or no?
Yes, sir.
So, since there can be solid bodies whose one dimension can be very large compared to the other two dimension, or whose two dimensions can be very large compared to the third dimension. We can have three types of expansion for solids. The first type of expansion of solids is known as
Linear.
linear expansion. But remember, all solids expand in volume. We are just taking linear expansion. So we are assuming these are only 1D bodies. Do we understand? 1D bodies we are taking. One dimension is very
Yes, sir.
large, thin wire, thin rods, these type of bodies. One dimension is very large and the other two dimensions are very small. Do we understand this? Yes or no, no or yes?
Yes, sir.
So now what we have? We have a rod or a wire whose original length is L0 before heating. And then when you heat it, when the temperature is changed by, let's say, delta theta, and I will always call temperature as delta theta because delta T will be using for time and that will also come. So this is the original length L0, and when you increase the temperature, the length becomes L0 plus delta L. This delta L is the change in length. Do we understand this?
Yes, sir.
Now this delta L will be proportional to the original length L0, yes or no?
Yes, sir.
This delta L will be proportional to the change in temperature delta theta, yes or no?
Delta T. Yes, sir.
And this delta L will also depend on the material, yes or no?
Yes, sir.
If the rod is made up of iron, it will expand in a different way. If it is copper, it will expand in a different way, and so on. Yes or no? No, yes.
Yes, sir.
If I put these things together, I will get the formula. Change in length delta L will be alpha into L0 into delta theta. This alpha is a constant depending on the material, and this constant is known as the coefficient of linear expansion. Do we
Expansion.
understand this?
Yes, sir.
This alpha is known as,
Coefficient of linear expansion.
so I can write the final length L as L0 plus delta L. Do we understand this?
Yes, sir.
Now the same, now here we have assumed that alpha, here we have assumed that alpha remains constant with temperature and alpha remains constant with length. But that may not be the case always. So we can write the differential form of the equation as well, and that is very good to write. The differential form of the equation looks like this: dl means the small change in length. Do we understand this?
So,
Will be equal to L alpha into L length at any temperature into d theta, or I can write dl by d theta is equal to alpha into L. Do we understand this? So this has gone above our head saying bye bye, bye bye, bye
I
bye.
understand, sir.
Everyone understands this?
Yes, sir.
Everyone has noted this down?
1 minute, sir.
Re- Wait, I'll just give you that full formula as well, and then you can note it down. And I'll give you 2-3 minutes to note it down. Just one sec. Let me put that formula as well. So this becomes the full formula of change in length. If alpha varies with distance, you can write alpha as ax plus b, whatever, because alpha will be given as a function of x. Yes or no? So you can
Yes.
write the total expansion will be alpha into, I will write it as delta theta change in temperature into dx. Do we understand this?
Yes, sir.
If alpha is given as a function of t, your change in length becomes like this. Yes or no?
Yes, sir.
Okay, I'll give you 2 minutes to note this down. I'm expecting a question on this. Let's see if you, that's why we'll do couple of questions on this topic. This is the one. The designs of a physical instrument requires that there is a constant difference in length of 10 centimeter between an iron rod and a copper cylinder laid side by side at all temperatures. Alpha for iron is given and alpha for copper is given. Might require some calculations. I'll give you time. If this question comes, they might not ask you the length, they might ask you the ratio. So even if you can tell me the ratio, that is good enough. Do you understand the question? Because the question may not require so much of calculation. Or they can give alpha of iron is 2 times alpha of copper or something like that. The purpose of this question is not to get you into calculation. The purpose of this calculation is to understand how it is done and then get the relation between them. So if you can tell me the relation, that is good enough. Do you understand this?
Yes, sir.
Your time starts now. That is absolutely correct. The ratio is 17 by 11. And how did you get it?
Sir, the difference must be constant, no, sir.
Yes, the difference
Uh,
must be
that
constant.
me that means the
Length of
expansion should be
iron
constant.
minus length of copper should be, oops. The first equation that you will make, you will have to first see who has more coefficient of expansion. Copper has more coefficient of expansion, iron has less. So iron rod will be lengthier. Yes or no?
Yes, sir.
So length of iron rod minus length of copper rod should be 10 centimeter. Yes or no?
Yes, sir.
But the change in length has to be same, otherwise the difference will be different. So basically, change in length, even if you differentiate this, change in length of copper will be equal to change in length of iron. Yes or no?
Yes, sir.
So alpha of iron into length of iron into change in temperature should be equal to alpha of copper length of copper into change in temperature from here, from this equation, which is equation number 1, you get one equation. From this equation, equation number 2, we get length of iron divided by length of copper should be equal to
17 by 11.
17 by 11. You can now put this in the previous thing and you will get your answers. Answer that is given to me is this one. Now, once you understand, the calculation is different. The calculation should be simpler if it comes to you. It's because of 17 by 11, this thing is becoming so difficult. If it had been 1:2 or 2:1 or something like that, the answer would have been simpler. Do we understand this? Yes or no? No, yes. Do you understand this? Yes or no? So let us now do this question. A brass rod and a lead rod, here I think the calculations are simpler. 80 centimeter long at 0 degrees Celsius are clamped together at one end. So at one end it clamped together and their free ends are coinciding. That means their length are same. Yes or no? The separation of the free ends of the rod if the system is placed in a steam bath. What will be the difference between the two free ends? Simple question. I'll give you 2 minutes to solve it. So how did you get the answer? Basically, what you need to find, both the lengths are given as 80. You have to find out the difference in their lengths. Yes or no? So length of lead, because it has got more expansion, minus length of brass, that will be equal to their original lengths are 80 into 1 plus alpha of lead minus 1 minus alpha of lead. So basically it will become 80 into 28 minus 10. Yes or no? Into 10 raised to the power minus 6. Do we understand this? Multiplied by 100. Do we understand this?
Yes,
Yes
sir.
or no? So that I think will give you the result as 0.8 mm. Everyone got this answer? Can I have raised hands from everyone that we got the answer? Okay, well done. Now let us come to this one. And from this chapter, this percentage wale question comes a lot. So this is the next question. And I hope you can give me an answer. What is the percentage change in the length of a 1 meter rod if its temperature changes by 100 degrees Celsius? So I'll give you 2 minutes to give me the answer for this. So how do we get this? It's very
Sir,
simple.
percentage change equals to change in length by original length
Change in
into
length
100.
into 100. And change in length by original length is alpha into delta theta multiplied by 100. Yes or no?
Yes, sir.
So once you put the values, you should get the answer very simply. Yes or no?
Yes, sir.
Then this question comes, an interesting one that shall remind you of what we had done some classes before. Take a deep breath, and if you can solve this question, congratulations. A uniform solid sphere is rotating with an angular velocity omega about a diameter. The temperature is now increased by 100 degrees. What is the new angular speed? Take your time. You can solve this question. Well done. Option C is the correct answer. Well done. How did you get? That is more important than anything else. How did you get?
Sir, I1 omega 1 equals to I2 omega 2.
Okay. I1 omega 1 is equal to I2 omega 2.
So that the I is 2 pi 2 by 5 pi 2 by 5 into m into r square.
So this I1 is 2 by 5 m into R1
R
square
square. Yes, sir.
into omega is
Omega
omega
1.
naught. Omega naught is given. That will be 2 by 5 m. Mass remains same. R2 square into omega 1
Omega 1.
into omega 2. Let me not call it as omega 1. Yes, what?
Mass remains same. So
So
2 by 5
everything
m
here is
cancels.
cancelled. So
Omega 2 equals to that radius is there, no sir. It will expand linearly radius.
yes, well done. So omega 2 will be equal to omega naught into R1 square by R2 square.
Yes,
Yes or no? So you can
yes
write
sir.
it. You just had to use R1 is, let us say, R naught, and this is R
R
naught
naught
into
plus
1 plus
1 plus
alpha
alpha delta
delta
theta
theta, and this
square.
square. So this gets cancelled. Now you can take it into the numerator and it becomes 1 minus 2 times alpha delta theta. I have applied binomial expansion. Do we understand this?
Yes sir.
Well done. If you could do this, good. So now you just put the values and you will get the answer. Remember, whenever a question of alpha comes and you get all these good powers, 2, 3, 1 by 2, be very happy, because then you can straight away use the binomial expansion and get your answers pretty quickly. Do we understand this?
Yes sir.
Now, same is the case. This question could be asked in a different way. Let me put that question. If the radius of a sphere increases by 2%, you can take this question as error and measurement, you can take it as expansion, you can take it as rotational motion, doesn't matter. Find the percentage change in I. What is I? Moment of inertia.
Moment of inertia.
2 minutes you have to give me the answer. How did you get 4%?
Sir, that error and measurement, that is delta I by I into 100 equals to 2 into delta R by R.
So basically what you got to remember is uh, di by I, percentage change, will be dm by m plus 2 times dr by r. We remember this?
Yes sir.
Okay. So you can use this and get your answers quickly. Shall we move ahead in life?
Yes sir.
So the next question is, the next topic is not the question. The next topic is, I think this is enough for thermal, for linear expansion. We are still into linear expansion, but we are actually seeing its uses. Where does this linear expansion come? Yes, anyone, any doubt?
No sir.
Thermal stress. You might have heard about stress.
Yes sir.
This is thermal stress. What is this thermal stress? If a rod, if I have a rod and I keep the rod like this, and then I increase the temperature of this rod by delta theta, will there be any stress? Now, the stress We have not done that chapter on properties of matter, but we're going to do it. Probably it's a small chapter. We'll do it someday. After thermodynamics, we will move on to electro, and we'll move on to optics, then modern, and after that, probably we'll move on to that. But you just need to understand small things. Whenever a body, you apply an external force on the body, something happens. What happens? That external force tries to, obviously, it's trying to accelerate the body. Apart from accelerating the body, if I am applying force on this pen here, it is not accelerating. Yes or no? But
Yes,
this
sir.
force is doing something. What is it doing? It is trying to
Compress this.
it is trying to change the size, shape, or geometry of the body. Whenever the size, shape, or geometry of the body changes, we say that the body is strained. Body has undergone a strain. Body has undergone a
Strain.
strain. Now, whenever we talk about this word strain, and we will understand this term strain, I represent it by epsilon. This is a change in dimension, change in the dimension upon the original dimension. So, if a body changes its length, that will be change. It will be strained. It will be strained because of the change in length. So, change in length divided by the original length will be the strain developed. Do we understand this?
Yes, sir.
Now, whenever a body is strained, that means the length has been changed, or the area or volume has been changed, or the shape has been changed. It will try to come back to its original position. Yes or no?
Yes, sir.
That property of the body is known as huh? I've told you that property. You've done questions on it. Elasticity. Perfectly elastic collision. What was that? The body was getting strained. The body was changing its shape, maximum deformed shape, and then it was trying to come back to its original state. Perfectly elastic collision. That bodies are known as elastic bodies. So as soon as you change the dimension, or you try to change the dimension of the body, internal forces try to bring the body back to its original condition. Those internal forces per unit area is known as stress. Stress. Sigma. Internal forces, or we call it restoring forces per unit area. Now, this is a wrong concept, and I had a few discussions on this with some really big teachers. This sometimes, if something is very basic and someone doesn't understand the basic, and they call themselves the biggest teacher in the country, it sounds stupid. Anyways, what comes first, stress or strain? It's a question. Have you seen that stress strain graph?
Yes, sir.
That what is that experiment known as?
There is some three
Elastic
entities.
limit, elastic limit. What is that graph known as? Elastic limit is there, proportional limit is there, Hooke's law. Heard about Hooke's law? Stress strain graph, Hooke's law. The graph is drawn, strain is on the x-axis and stress is on the y-axis. Yes. And I had a discussion, and someone was telling me this is the only graph in the universe that is drawn ulta, reverse order. I said, why? And like it's just because stress is plotted on y-axis, and y-axis is the dependent variable and x-axis is the independent variable. So stress should come first, stress should come on the x-axis and strain should go on the y-axis. Then I tried to make him understand, sir, it is not that way, it is the reverse way. When you exert forces on a body, that force does not create stress. That force creates what?
Strain.
Strain. And because of that strain, the internal forces start to act and try to bring the body back. So strain creates stress. Stress does not create strain. So strain is the independent variable. Do we understand this? Anyway,
Yes, sir.
now if we assume that the body is perfectly elastic, what will happen is whatever be the external forces, the same would be the internal forces, otherwise the body will not come back to its original state. And therefore the external forces become equal to the restoring forces, and that is why we have this concept that stress creates strain. No, strain creates stress. You understand this?
Yes, sir.
Okay, now when I keep this rod free and I change the temperature, it can expand, right? So there is no strain and therefore there is no stress. The strain is, the length has changed, but it is not trying to come back to its original position. Do we understand this?
Yes, sir.
So there is no strain as such. There are no internal forces which are trying to pull it back. There is no stress. There is no thermal stress. Now, if I hinge it, if I fix it from one end, so I do the same experiment, but now I am fixing it from one end. And now I change the temperature of this rod by delta theta. Now what is happening? If I still change the temperature of this rod, it is still free to expand. It can expand, and therefore there is no strain or no stress developed in this rod. Do we understand this? Because there is no force exerted on this rod. It is free to move in one direction. Are we understanding what I'm saying? But
Yes,
now
sir.
if I do this thing, what I'm going to do, I am going to restrict it from both the ends. Now I'm restricting it from both the ends, and now I change the temperature by delta theta. Now what will happen? Now it will try to expand, but it is not allowed to expand. Now the stress will come in this rod because of the strain which is produced in this rod. Do we understand this?
Yes,
Yes
sir.
or no? Now, whenever we talk about stress and strain, we talk about the Hooke's law, we talk about modulus of elasticity. This gentleman comes into the picture. Why? What is this Y?
Young's modulus.
Sigma by epsilon. Do we understand this?
Yes, sir.
Now, when I'm trying to change, when I have restricted this rod, the length of this rod is L, a strain comes in this rod. That is delta L by L, because it is not allowed to expand. It wants to expand, it is not allowed to expand. So the rod is strained. Do we understand this?
Yes, sir.
And the strain in the rod becomes equal to alpha into delta theta. Do we understand this?
Yes, sir.
Because of this, stress comes in this rod. How much will be the stress in this rod? This sigma will be equal to y multiplied by strain, y into epsilon naught, or it becomes equal to y into alpha into delta theta. Do we understand this?
Yes,
This
sir.
is known as the thermal stress. The thermal stress in this rod. So when the rod is not allowed to expand, stress is created because of the strain created in the rod, and that is known as thermal stress. Do we understand this?
Yes, sir.
Now, in this case, if I increase the temperature is increased, what type of thermal stress will come? We'll just discuss this and we are done with today's class. If the temperature is increased, what type of thermal stress is developed? If temperature is increased, what type of thermal stress is developed? Remember, there are two types of thermal stresses in this case. One could be compressive, one could be tensile. Compressive thermal stress is trying to compress the rod. Tensile stress is trying to extend the rod. Which type of thermal stress is developed in this rod because of temperature increasing for the rod? Is it compressive or is it tensile?
Tensile.
Why tensile?
Because rod try to expand. No, sir.
Rod tries to expand, but it is not allowed to expand. That means it is being compressed. You understand? So internal forces are compressing it. Do we understand this?
Yes, sir.
So it's ulta of what logic, what your common, just common logic. Oh, since it is blocked from both sides, it is compressive. No, stress does not come because of blocking. Stress comes because of internal forces. It wants to go, but it is not allowed to go. Do we understand? So in
Yes, sir.
that case, the stress is compressive. No, the stress is tensile. Do we understand this?
Yes, sir.
If the temperature of the rod is decreased, then it wants to contract, but it is not allowed to contract. So internal forces are extending it. Yes or no?
Yes, sir.
No, I said reverse, I think. When the temperature decreases, the rod wants the logic when the temperature increases, the rod wants to increase in length, but it is not allowed to increase in length. So the uh, the stress is tensile. If the temperature decreases, the stress is compressive. Do we understand this? Have we noted it down?
Yes, sir.
Okay. I have written reverse, yeah. I have written reverse. I have explained Sida, but I have written reverse. Is that so? If the temperature increases, the rod wants to expand. Yes, the rod wants to expand. So the rod wants, yes, right. Written it correctly. Okay. Do we understand this?
Yes, sir.
Okay. This is a question that comes here. One end of the rod is free. What will be the strain produced in the rod?
0, sir.
Why?
Sir, strain is alpha delta theta, sir. Sorry. I thought it's stress.
Hmm? What type of strain is produced in the rod? Yes.
Alpha delta theta, sir. A.
The rod is free to expand. So there is no strain produced and therefore there is no stress produced. 0 is the answer. I told you that, no? If it is free, it will expand. The internal forces does not come into the picture because it can expand. Yes or no? See, to create a thermal stress, it must be constrained. Do we understand this?
Yes, sir.
It must be constrained. If it is not constrained, a body kept like this, if I apply force on this rod, it is not constrained. So there may not be any stress developed in the rod. Stress will only be developed when something tries to change it and it is not allowed to change. Getting my point?
Yes, sir.
Okay, so in this case, the answer is 0. So basically, to produce this strain, what we need is we need some sort of an external force, some sort of an external force. Oops, what has happened? Some sort of an external force which causes it to which causes the internal restoring forces to come into the picture. If internal restoring forces come into the picture, then only you will have the thermal stress coming. Do we understand this?
Yes, sir.
Okay. A steel rod of length 1 meter rests on a smooth horizontal base. If it is heated from 0 degrees Celsius to 100 degrees Celsius, what is the longitudinal strain developed?
Sir, that will be 0, no, sir.
That will be 0 because there is no external force present. Do we understand this?
Yes, sir.
Okay. I think we are done with this. I think here I have written reverse. I am confused. I have written it reverse here. I have written it reverse here. If the temperature increases, the rod wants to expand, it is not allowed to expand. So the stress has to be compressive in nature. I've written it reverse. If the temperature falls down, it has to contract. It has not been contracted. So the stress would be tensile here. I think that should be correct. Okay. So with this, we come to an end for this one, thermal stress. In the next class, we will go ahead and see the other functions of, we are still into linear expansion. We are seeing what happens when the length of a rod changes. So there are 2 or 3 more applications that we will see. We will see that in the next class. Have you understood what we are discussing today's class? Thermal stress, I have 2 or 3 more examples which we'll do. Don't have time to do it, so we'll do it in the next class. Okay.
Okay, sir.
Okay, take care. Bye bye.
Thank you, sir. Bye. Have a
Bye.
good day.